Again, this is a 4-day unit. If you were not here last time, you need to pick up notes in the homework packet. And then my answer keys for this unit, I'll just put right here. If you'd like to check your work, you want to check day 1, see how you did. The focus of today is on a geometric sequence. Arithmetic sequences have a common difference, which means you can add and subtract to get the other terms. A geometric sequence means it has a common ratio. That means you can do what to get the next term? It has a common ratio, you should be able to do what? Multiply or divide. So instead of using D for difference, we're going to be using R for ratios. Is that okay? Okay. Alright, well, arithmetic sequences have a common difference, geometric sequences have a common ratio. We'll be using R. And you can build a geometric sequence by multiplying each term by a constant, or dividing, multiplying or dividing. So, the recursive definition, that's the one that compares the next term to the term before it. So if I want any term in the sequence, I would take the previous term and multiply it by R. The explicit formula is a little bit harder, just like the other one. This is one that you have to memorize. And you need to that one too, but for the explicit formula, you take the first term. So it's not a sub 0, it's just the first term. You multiply it by R, and you raise it to the n minus 1 power. I'll show you. So when you're filling in the equations, these are the two numbers that will change. This number right here will always say n minus 1. Okay, so the first thing we're going to do then is determine if these are geometric. If they are, we're going to find a sub 1, r, and the next 3 terms. So for example, a, is there a common ratio between those terms? From 3 to 6, we double, then we double, then we double, then we double. So is it a geometric series? Is our sequence? Yes. A sub 1 equals what? 3. R equals a doubling, so my common ratio would be 2. And if I needed to find the next 3 terms from 48, the next 3 terms would be 96, 1, 92, and 384. Okay, look at the next one. Is it geometric? Times by 2, times by 2. No, so you're done. This is not geometric. What's it called? Arithmetic. Why is it arithmetic? No. Okay, looking at this next one. Ooh, it's hard to tell. So, hold on, let me think about this for a second. Are we tripling here? I don't know that we're tripling. Okay, so let me remind you something. If you have x squared and you're multiplying it by x to the 5th, what do you get? X to the 7th. So you add it, right? So if I multiply that by x to the 5th again, it would be x to the 12th, right? If I multiply it by x to the 5th again, it would be x to the 17th. What would the common ratio be between all of these? scientific. And the next three terms would be 3 to the 17th, then. And then somebody new?
Right here.
Not better fractions than next problem. Ooh, ugly. Are you okay with that? Make sure all distractors are put away, please. You don't like that, or are you okay? Oh, look at the fraction ones then. Oh, that's on here. Okay, the fraction ones. When I'm looking by multiplying and dividing with fractions, I just need to see if the numerators or the denominators, if something's happening to them. So, ignoring the negative, my numbers are going up or going down? Down. So this would be a division problem. So if this was geometric, then my ratio would be 1 over something. So what's happening? I'm going from 1 over 1 to 1 over 2 to 1 over 4 to 1 over 8. Yeah. So my ratio is going to be 1/2. Except it's flipping. So on the arithmetic, can I go negative, positive, negative, positive? No. On arithmetic? No. Because I can't go back and forth and back and forth. But on geometric, if I have a common multiplier, can I go from positive to negative to positive to negative? Is that okay? So my ratio would just have to be negative. Do you want me to show you that one more time? Did you guys get it? Are we okay? Make it really good. Okay. What's a sub 1? And then what would the next term be after 1 over 16? Okay, somebody new? What would the next term be? The same people who said it, so somebody new? Positive, and then the negative 1 over 1.8. Okay, cool. Somehow Austin got to be in the front seat again, and he volunteers a lot, and so I have to stop on him. Okay, any questions with that? Fractions down are very fun. Okay? Alright, let's look at the next one. Write the explicit formula for each geometric sequence, then find the terms indicated. So, this is, we're told it's geometric. What's the ratio between them? Alright, it's 3. Now going back to the formula, a sub n equals a sub 1 times r to the n minus 1. We need to know what r is, and we need to know what a sub 1 is. Good. A sub 1 is, so take these two, plug them in. A sub n equals 4 times r, which is 3, to the n minus 1. This is your formula. Oops. That's your formula. That's the equation that you can use to find the 10th term. So if I want to find the 10th term, I plug in 10. It will drop the 1, so subtract 1. So if I want to find the 10th term, I say 4 times 3 to the 9th, because it's 10 minus 1. And now, these are multipliers, right? Which means it's going to be growing very fast. These numbers should be big. 3 to the 9th is a very small number. I don't know what it is. Back and forth.
What is the 19,000.
Aaron, do you have it?
78,732.
That's the 10th term. That's the 10th term. I really don't know how I feel about jumping clear to this already. I'll show you, but here's the thing in a second. Hey, flip open your homework. Wow, that was fast.
No, but flip, well, I mean, we're not done, but. That means your ratio is negative if it's flipping signs.
So you're trying the first 4 really quick, and then maybe looking at number 5. 10 divided by 18. What do you do on something like number 2 where it's not quite obvious what the ratio is? The common ratio is going to be this divided by this. So R would be 10 over 18, which is 0.555 if it were geometric. But if it were geometric, that would mean that 6 divided by 10, are you with me? Should be the same number as this. What's 6 divided by 10? 0.6. So these are different ratios. That would mean that 4 divided by 6 is the same ratio. Well, that's 0.666, whatever. So are these the same ratios? That means it's not geometric. Probably. It would be, what's the ratio? It's 2 less. The difference is 2 less than the one before it. Yeah. So it's technically not arithmetic, technically not geometric. There's probably a pattern we can write. I don't know.
Would that be something that you
No, not necessarily. I would take a look at that for a minute. It might be kind of like a I don't know. But it'll be something really 18 minus 8 over n. Is that? So, it would have to be n minus 1, because if you plug in 1, oh, that doesn't work, n, no, it's not working there. Because if it's n minus, or if it was n, and you plugged in a 1, then that would mean your first term would have to be 10.
it doesn't have to be n, have to subtract.
If this was a 10, the first term works, right? Oh, no, that doesn't work. If it were, this really doesn't matter, but I just wrote the time. If that was a 1, that would work. If that was a 2, it no longer works. So there's something, but it's not any of it. It would look funny. Yeah, I'm not sure. Okay, what about number 1? Is it geometric? Yes? What's the common ratio? R equals 1/2. Okay, so instead of saying divide 2, I'm saying 1/2, right? It's the same thing. Number 3, is there a common ratio? Yes? R equals 5. Number 4, is there a common ratio? Yes? R equals -3. We know it's negative because it flips back and forth. All right, let's look at number 5. 7? After 5. Find the common ratio, the 8th term, and the 3 terms in the sequence after the last one. So, basically find the next 4, which I'm still not practiced writing the equation. Common ratio in this case would be what? Let's change this instead of the 8 terms. Let's change all the 8. It's big fast, right?
No, the 8th term.
I know, but did you write the equation? Write equation. Add that to your list. Write equation. Stop whining. A lot of you are whining. I go home. Okay, what's the common ratio? R equals 2. We'll ignore the 8th term for now. Let's let's write the equation. A sub n equals what? What do you need in this formula? You need a sub 1, which is 3. You need r, which is 2. And then you raise it to the n minus 1. It asks you to find the next 3 terms, and then it asks you to find the 8th term, so really you just need to find the next 4. So really you don't need the equation, but you will on the test. So I want the practice of writing the equation. So after 24 becomes 48, then 96. Did you do this on your homework?
Yeah. Hold on to it.
Or on the notes, I mean?
Yeah.
Yeah, well, there you go. Now let's practice number 7, because fractions freak everyone out. What's the common ratio? What am I doing? The denominator is tripling, right? So my common ratio is 1/3. A sub 1 is 2. So to write our equation, A sub n equals the first term times the ratio raised to the n minus 1. So that n minus 1 is always there. Now I just need to triple the denominator for the next 4 terms. So it's going to be 2 over 81, 2 over 243, and need one more thing, the 8th term. What? I have no idea. Is that helpful to see it a few more times?
Wait, so we don't have to solve the equation, we just have to write it?
Yep.
Yeah.
Because if this would have said the 18th term, then you would plug in 18, right? The problem with a geometric series is when you get much higher than 8, 9, 10, 11, your numbers are getting really, really big. So you won't probably ever see it.
Number 6.
6 is big? Yeah, probably. Lots of zeros?
Flip back to your notes really quick. If you could just finish the problem that you're on. In this case, I don't know the ratio, and I don't know the next term.
Let me remind you really quick what we did when it was arithmetic sequence. If it was arithmetic and I said this was 3, we left a few spaces, I don't know, we can do a lot, and then we said that this was 24. The first thing I would do is I would find the full difference. So from 3 to 24, that's what? 21. And then I need to see how many spaces, not how many spaces, but how many jumps, I guess there are, from the 3 to the 24. How many are there? 5. So 5 of my differences need to add up to be 29. Is that okay? Which means my difference is a decimal. So you divide it out, and you know that each difference is 4.2. So then how do I get my next one? Add 4.2, so it would be 7.2, and then 11.4, and then 15.6 would be about. But we'll probably get through the first. Oh, you're leaving. Wait. We'll probably get through the first half of 11.3. Okay. Yeah. And then that's how we would carry on. Is that okay? If I had something in your order, I said the first one was 2. Yeah. And then this one was 50. And I know it's geometric. That means not my common difference, but my common ratio would have to be the same. So how many times bigger is 50 than 2? Now we need multipliers. How many times bigger is 50 than 2? 25. So this is a times 25, which means if it takes me 2 steps to get there, each step would have to do what? It's a multiplier. So if I multiply 5 and then 5 again, what do I get to times 25? Does that sort of make sense? So that's what we're going to do. Let me show you one more. If I said these are 3. Sorry, hold on. I think this will work. An 81. Okay. How many times bigger is the 81 than the 27? Are these all on your homework?
No, that one that you just did is number 9.
Oh, there you go. This one is not.
No, this one's 9.
This one's number 9, apparently on your homework. What's the big ratio from the 3 to the 81? 27? So this is 27 times bigger. How many times have I multiplied to get that 27? 3. So is it safe to say that r times r times r would be 27? Okay, so 27 equals r cubed. How would I get rid of the cube? What's the cube root of r? So that means my common ratio would have to be what? 3. Now let's see if it works. 3 times 3 is 9. 9 times 3 is 27. And is 27 times 3 81? Yeah. Does that kind of give you an idea of how we're going with this? Okay, so now that you have problem 9 then, you're welcome. Let's go to part B. We need to find 8 of 2, 8 of 3, and 8 of 7. So first start, what is the big multiplier from the 2 to the negative 54? From 2 to negative 54, how do you figure that out? It's a times what? Negative 27? So just divide those, right? Chris, you still okay? 54 divided by 2. Now how many jumps does it take to get from the 2 to the 54? So r times r would be a negative 27. From that, can you figure out what the common ratio is? What is it? So take the cube root. And my common ratio is negative 3. Is that okay? Can I get a 5, 4, 3, 2, 1? How well do you get that? Okay. And then you'll take whatever root. And then divide it by the root. Yeah. So to find the next term, 2 times negative 3 is negative 6. And negative 6 times negative 3 is 18. And is 18 times negative 3 negative 54? It better be. So 1, 2, 3, 4, 5, 6, 7 times the 54 by a negative 3 would be a positive, because it asks for the 7th term too. 162. Times that by negative 3. I don't know, times that by negative 3. Negative 4 what? And then our last one would be a positive. I'm pretty sure it's the 1458, yeah? Real quick, Lane, was that your review?
Yeah.
On conversion? Was it graded already? Okay, here's one. You have a ball, and when it bounces, the height of consecutive bounces form a geometric sequence. So the ball will roll, it'll go down 24 inches, and then it comes up 18. And then it goes down 18 and comes up 18, and then down and up and down and up, right? So once it bounces to the height of 18, then it will fall, and the height is 17, then the height is 17. What are the heights of the 8th and the 9th bounce? Well, first let's talk about this. Read the problem one more time, see if you can figure out what the question is asking. And then see if you can figure out which one of these is the 8th and the 9th bounce. So when the ball bounces, the height of the consecutive bounces form a geometric sequence. What are the heights of the 8th and the 9th bounce? So if we make a game plan, we need to find the ratio We need to figure out what a sub 1 is. And then we need to write the equation so that we can plug it in then. Okay, so what's the common ratio? How would you figure it out? How did we figure out the ratio between the 3 and the 81? We divided, right? So if I wanted to find the common ratio between these, other way around. The ratio is 18 over 24. Which is what? 24? Okay. Is that all right? What is your a sub 1? 18. What is the 24? Why is this not the first bounce? This is a sub 0, right? That's not the first bounce. The first bounce is technically here, and then that's the second, third, fourth, fifth, sixth, seventh. So we're looking for the height of those two, right? A sub 1 is 18. Because once it falls off the ledge, that is not the first bounce, that is the first bounce. So technically the bounces are the dotted line. That's the first bounce, that's the second bounce, that's the third bounce. Is that okay? All right, do we have enough information to write the equation? A sub n equals, what's the formula? A sub 1 times 3/4 raised to the n minus 1. So to find the h bounce, what do we have? Once you plug in the 8, it will become a 7. Yep. What do we have? Do it again. 2.4. We now do math. Enter, enter. Just 2.4. Okay. But it did give you a fraction. Okay. If I want the ninth term, 9.
What do we get? What?
1.8-ish inches. How do you feel about it? Good, almost done. Okay, now let's talk about the geometric mean. The geometric mean is very similar to the arithmetic mean, except for original plans in the back. So the 9th and the 11th term of a geometric sequence is 45 and 80. What are the possible values for the 10th term? So we've done something similar to this. We're looking for that middle term. How many possible answers are there? Just one, or is there more than one? Okay, well let's see. Ignoring this geometric mean, what did we do before? What's the difference? What's the ratio between those two? How would you find it? 80 divided by 45 is what? 7. Okay. So that, how many jumps does it take to get there? 2. So this 1.77 would be what? R squared. Because there's 2 r's that it takes to get there. So how would you find r? Is that okay? So the middle term is, now what do I do with that? I take the 1.33, how do I find this term? 59. That's one possibility. Is there another one? Negative? Remember you said negative gets 2 points. Is negative the other option? What would r have to be in order to get a negative 59 points? R would just be negative. Is that okay? Sure. Yeah. Unless it tells you in the problem that they're all positive. either answer. Good. So the geometric mean, the square of the middle term, sorry, hold on, the square of the middle term of 3 consecutive positive terms is equal to the product of the other 2 terms. That's confusing. So that means if you have an x, y, z, and I take the square of the middle term, that equals the outside 2 multiplied together. Yes, Chris?
So, we times 45 by 1.3.
58. Did I write it down? I could have written it down on 1 point. It depends on how many decimal places you went to, maybe. I don't know. 59 times 1.33. I got 59.58, so I can come look. If you just said it by 1.3, maybe it was different. I don't know. Yeah, I think that was probably it. So, as many as possible. Maybe as much as possible. Okay, so does that make sense? I want to find the middle term. I multiply the outside 2, and then I increase the square root. So you can do it the way we have been, by finding the common ratio, and then taking the square root and multiplying. Or, if you wanted to find this middle term, the middle term squared is the outside 2 multiplied together. Personally, to me, this is just one more thing to memorize. I'm okay if you do the okay, so what is 9180 times 25? Big number, okay? So then let's take the square root of whatever big number that is, and what does x equal? Does this tell you the common ratio? No, but do we care if we figure out what the other number is? Not really. You could if you needed to. Could you do the geometric mean if you knew that this was 75 and that this was 5? What? Did you already take the square root? That means this right here is the missing term. Could you use the geometric mean if you had 2 spaces in between? No, because the geometric mean would give you the number that goes right in between those 2. That would work, just giving you the middle number. Could you use the geometric mean if you had this? And what number would it give you? It would give you this number, right? Because the geometric mean is always going to give you the absolute middle. Is that okay? And then you could do it again if you wanted. Now, using the geometric mean, you're going to take square roots, right? Can you take the square root of a negative? No, so this is assuming that it's always positive, right? That's right. Okay, let's try part B. So if I wanted to find this term right here, let's call it x, what would you do? X squared equals, don't forget this is squared. Multiply those and then do what? X squared is going to equal something ugly, and then we do what with it? Take the square root. And what do we get? Say it again. Again, does not tell me the ratio, it just tells me the middle number. So there's 2 ways to look at the exact same problem. Is that okay? Okay, you ready to begin? Is that it?
Thanks for watching. Oh, wait, is that it for, yeah, it is. Okay,